Hello everyone, welcome back to our channel. We are going to solve a very interesting question today. Its name is DIFFK. First of all, let's try to understand the question. Given an array A of sorted integers and another non-negative integer B, find if there exist two indices I and j such that A of I minus A of j is equal to k, where I is not equal to j. Return 0 for false and 1 for true for this problem. Okay. So let's try to solve this question. Let's try to understand this question with the help of an example first. So 135, is there a pair of numbers whose difference is 4? Let's see. 1, 3, 5, and this is A, and the number that is given to us is 4. So we have to find two numbers whose difference is 4. The basic brute force approach is very simple. We take every pair of numbers and find whether their difference is 4 or not. Oh, that's a simple approach. So let's try to write the pseudocode for that. So how do we do this? We can iterate the array from 0 to a dot size minus 1 with an iterator I. Inside this loop, we add another loop. So we iterate the array from I plus 1 to a dot size minus 1 with an iterator j. So with this, we have all the possible pairs in I and j. Now, if inside this loop, if a of j minus a of I is equal to b, the target value that we have, we can simply return 1 over here. Otherwise, if we come out of these loops and we still haven't found a pair that gives us the difference b, that means for all possible pairs, this just doesn't exist. In that case, we have to return a 0. And that is it. But the problem with this approach is the time complexity is O of n square, right? We have to reduce this time complexity. So there's a subtle hint given to us that this array is sorted. Okay, it is a sorted integer array. So now look at this very carefully. We are going to use a two-pointer approach to solve this particular question. So there are two things you need to know before you apply two-pointer approach. First is where to put the pointers. And second is how to move the pointers. Okay, you need to be 100% clear on both of these things before you can apply the two-pointer approach. If you don't have the answer to these two questions, you cannot apply two-pointer approach for a question. So let's try different positioning of these pointers. So let's take an example to understand this better. 1, 3, 8, 9, 10, 11, 15. And we want the difference to be 6. Okay. Now, if we put the pointers at either ends, okay, this is the placement that we are trying right now. Pointers on either ends. This is pointer 1, this is pointer 2. Currently, the difference is 15 minus 1, 14. 14 is greater than 6. If, okay, look at this very carefully. If we move P1 forward, the difference decreases. And if we move P2 backwards, again the difference decreases. We want to decrease the difference, but we don't know which pointer to move. So we have placed the pointers, but we don't know how to move the pointers in this particular placement. Now, if we place them at the beginning, currently the difference is 3 minus 1, that is 2. To increase the difference, we will move pointer 2. To decrease the difference, we will move pointer 1. Let me just write that down. To increase the difference, we move pointer 2 forward to decrease the difference, we move pointer 1 forward. Okay, this is the rule that we are going to follow from here on. 3 minus 1 is 2. We want to increase the difference. So move pointer 2 forward. 8 minus 1 is 7. 7 is greater than 6. We want to decrease the difference. To decrease the difference, we move P1 forward. Let's do that. 3 minus 8 is again 5. That is 5 is less than 6. So we move P2 forward. And 9 minus 3, finally, we got our answer. So we can return 1 as the answer. So in this case, we have answers to both the questions that are there, where to put the pointers, how to move the pointers. Okay. So this is how we are going to solve this particular question. Let me quickly write the pseudocode for this. Quite simple. So we are going to take 2 pointers, 0, and P2 is equal to 1. Okay. Now here we have to look at one thing. If A dot size, this is a corner case, is equal to 1, or it is basically less than 2. If there is 0 or 1 number inside our array, there obviously isn't any pair, right? So here we can directly return a 0. Now we get into the loop while P2 is less than A dot size. While P2 is within the bounds, what do? We first of all can check if A of j minus A of I is equal to our target or not. If it is equal to our target, we are done. We can simply return 1 right here. And if it is not equal to the target so far, it will fall under one of the two categories. Either the difference would be greater than B or less than B. If A of j minus A of I is less than B. Okay, what do we do in this case? Look at the conditions we wrote. To increase the difference, P2 moves forward. To decrease the difference, P1 moves forward. If the current difference is less, we want to increase it. To increase it, P2 moves forward. So we do a P2 plus plus, and else we do a P1 plus plus. Okay, so there is one corner test case that we have still missed. If while moving forward, P2 and P1 start pointing to the same number, and it's clearly mentioned in the question that P1 should not be equal to P2. To make sure that doesn't happen, what we will do is we will make P2 equal to maximum of P1 plus 1 and P2. So if P2 and P1 come to the same index, then P2 will be moved forward by 1 space. When we come out of this while loop, either we have already returned 1, we have found a pair, or we can simply return a 0 over here. Okay, why does this logic work? Because the array is sorted. That is why this particular logic works. Now let us move on to the code for this particular question. So let's look at the code for this particular question. So we'll take the first two variables as the pointers, pointer 1 and pointer 2. Pointer 2 starts from 1 while pointer 1 starts from 0. Now the corner test case, if A dot size is less than 2, right? We can simply return a 0 because there will exist no pairs. Now we go inside the while loop. While P2 is less than A dot size, we can iterate in this particular loop. And first of all, we can check if A of P2 minus A of P1 is equal to our target. Then we can simply return 1 as the answer. Otherwise, we can check if A of P2 minus A of P1 is less than B. Okay, this means that we need to increase the difference between the two numbers right now. How do we do that? By moving P2 forward. And otherwise, we can simply move P1 forward. Now, to make sure that P1 and P2 don't point to the same index, what were we doing? We were making P2 equal to max of P1 plus 1, comma P2. And that's it. When we come out of this while loop and we still haven't returned 1, that means that there is no such pair whose difference is equal to B. So we can return a 0 in this case. Let's try to submit this. So here you can see we are able to solve all the test cases. So thank you so much for watching the video, and whatever doubts you have, please feel free to put in the comment section below. I'll be more than happy to solve any doubts that you guys have. Thank you so much. I'll meet you in the next one.